In this video, we will explore one of the most essential and powerful concepts in both mathematics and programming called functions. The objective in this topic is about determining whether a relation represents a function. So let us define what is a function. Let x and y be two non-empty sets, like as shown in this figure, and a function from set x into the set y is a relation that associates with each element of x exactly one element of y. So it means to say, for every input in the set x, it maps exactly to one output in the set y. In another context, so let us assume we have a function machine f. So this is the machine f. And for every input x that I will put in the machine f, so it will process here, and the output will be only one, which is the output y. All the elements in the set X is called the domain of the function, and all the elements in the set Y are called the set of all images, or that is also called the range of the function. It is also represents as the value of the function at X, or the image of the X. In this example, we will identify the mapping relationship of the following diagram. So either the diagram is a one-to-one mapping, one-to-many, many-to-one, or many-to-many mapping. Then we will determine which are functions or not functions and justify or explain the answer. So if you will look at the diagrams A, B, C, and D, we can see that all of them have relations. So this is set X have a relationship with the set Y, and same goes as diagram B, C, and D. So let's identify the mapping on the diagram A. So in diagram A, we can see that for every input of x, this is exactly one output. 4 maps to -1, 8 maps to -4, 2 maps to -9, and we can see that the mapping is a one-to-one mapping. And identifying whether it is a function or not, as we recall in the definition of the function, for every input x, there should be exactly one output. And we can see that there's always one output. So it means the relation is a function. For the diagram B, so we can see that for the input 1, there are two outputs 1 and 5. Even the input 2 maps to only 1, which is 4, and the input 3 maps to only 1, which is 3. So we can say that this is a one-to-many mapping. And since the output is many, not exactly 1, so it means this relation is not a function. So we can just write this as a relation. For the diagram C, so we can observe here that for these two inputs, 0 and 5, it maps to exactly one output. And the input -5, it maps to only one output, which is 8. So it means the mapping is many to one output. So it's a many to one mapping. And since the output is only one, so it means to say this is a function. For the diagram D, so we can notice that for this input 0, there are two outputs 1 and 4. And when the inputs are -3 and +2, it maps to only one output, which is -2. So we can see that the mapping for this diagram is many to many mapping. And since the output is many, not one, so it means this is only a relation or not a function. In this activity, given a real-life situation, first, second, and third, describe whether the relationship is a one-to-one, many-to-one, or one-to-many mapping. So you can start by answering this question. In this example, given the following relations as an equation, we will determine whether y is defined as a function of x. Then, we will find the domain for those defined as functions. So when we say y is defined as a function of x, so we can write that f of x is equal to y. So it means to say x is the input and y is the output. So for the first given, absolute value of x plus y cubed is equal to 9. So first, since y is the output, we will isolate the y. So in isolating the y, we will move absolute value of x on the other side. So it will give us y cubed is equal to 9 minus absolute value of x. And then getting rid of the power 3, we have to get the cube root of both sides. So y is equal to the cube root of 9 minus absolute value of x. Then to be able to know whether we have only one output for every x, so let us try to put a number or a value in x. So let's say when x is 1, so we will find out that y is equal to 2. So there's only one output, which is 2. And if we will look at this cube root of 9 minus absolute value of x, irrespective of the value here, the cube root of any number is always defined. For example, if we have a positive number in a cube root, so it's defined as 1. And if we have a cube root of 0, it's defined as 0. And even if we have a negative number, the cube root of negative number is defined, which is also negative 1. So it means to say, whatever is the value of x here, and we take the absolute value of x and subtract to 9, it will always be defined. The y value is always defined. So we can say that for every input x, there's always one output y. And the conclusion is y is defined as a function of x. And since this is a function, so we have to find the domain, and the domain of this is any real number, or we can write that as interval, which is negative infinity to infinity, or the script of real number, which is r. For the next example, we have absolute value of y plus 2x equal to 9. So first, let us isolate the y again because y is the output. So the absolute value of y is equal to 9 minus 2x. And then since it's already isolated, so let us try to put a value in the input x. So let's say when x is 0, so when x is 0, the absolute value of y is equal to 9. And if we will define the absolute value of y, which is equal to 9, so y is equal to a positive and a negative 9. So as you can see here, it's very clear that when the input is 0, it will give us two outputs, positive 9 and a negative 9. So it means to say, for every x value or every input x, there are two outputs y. So the conclusion here is y is not a function of x. The next equation is x equal to 3. And as we know here that we are solving or determining whether y is defined as a function of x, meaning y is the output and there is no y in the given equation. So let us rewrite this as x is equal to 3 plus 0y. From this equation, you will notice that when I put any number in y, multiplied by 0 is 0. So it means to say the y value can represent any number, meaning the output is infinitely many. So we can say that this equation is not a function. Or we can describe this geometrically, since we know that the graph of the equation x equal to 3 is a vertical line passing at 3, 0. So we can see here that when the input is 3, there are infinitely many outputs. So if you will look at this graph, when x is 3, y can be 1, can be 2, can be 3, or 3.5, or 1.1, or -1, -2, so it can be infinitely many. So since there are infinitely many outputs, so we can say that y is not a function of x. For the next example, so we have to determine if the equation r s squared plus r squared equal to 1 defines s as a function of r. So this time, the equation is not given as x and y. The equation is given as r and s. So let's find out which is the input and output. Since we have function of r, so s is the output. So first, we have to isolate the s because s is the output. So in isolating the s, we have to move r squared on the other side. So we will get this equation. And then isolating the s squared, we have to divide both sides by r, and we will get this. And then getting rid of the power 2, we have to get the square root of both sides. And if we get the square root of both sides, we know that s is equal to plus and minus with this square root. So as we can see here, s is automatically with a positive and a negative, meaning for every allowed r value, there are always two output of s, which is a positive or a negative number. And you can notice here that I put allowed because I cannot put any real number here because there's a denominator here and this denominator cannot be zero. And there's also a square root. There's many restriction on this because when you have a square root or even roots, the the fraction here or the value here should always be zero or a positive number. So it means to say that s is not a function of r. Now in this activity we have three questions. The first question is a multiple answer, meaning the correct answer here can be two or more. Which of the following equations represent y as a function of x? So take note that y is an output here. And the first choice is given as a set of ordered pairs. So the first element is the domain or the input x, and the second element are the range or the output y. So you can check whether this is a function or not. And then for letter B, it's given as an equation, and letter C is also equation, and letter D is also an equation with its square roots. So you can answer this question. Then for the second question, so this is a multiple choice question wherein only one choice is a correct answer. So which one of the following functions has a domain of real number? So you have to find out which of the domain here represents real number. And for the third question is a multiple choice question again, which is an application. So here we can see that there's a table, the distance traveled, and the fare for every distance traveled. And the question here is, what is the domain of the function that describes the fare? So if this is the input and this is the output. So you have to know or you have to describe how will you represent the domain of this relationship. So you can answer this question again. The next objective is evaluating function. So let us define a function notation. In general, function is presented by any letter, say f, and usually we use f, sometimes it's g or h, and it takes an input x in the domain and produce an output y as the range. So the function notation is given as f of x is also equal to y. So f is the name of the function, x is the input, and y is the output. So we have here a given function from set x into a set y, and the name of the function here is a function g. So for every input x, the output is a square root of x. So the output here, let's say when the input is 0, so square root of 0 is 0. So g of 0 is the output, which is equal to 0. When the input is 4, so we put 4 in the x, so meaning the output is square root of 4. That is a g of 4, which is equal to 2, because the square root of 4 is equal to 2. Then the second function is given as capital G of x is equal to 3. So the input here are 0, -2, and +3. So we can see here that if we put 0, -2, and 3 in the given function g, the output is only 1, which is always 3. So we can see that there are 3 inputs and the output is always the same, which is equal to 3. There's only one output. So g of 0 is 3. G of -2 is also 3, and g of 3 is also 3. The next example is about evaluating function. If the function is given as x minus b over x minus a, f of 7 is equal to 0, and f of 6 is undefined, then what are the values of a and b? So let us start from the given function f of x equal to x minus b over x minus a, and let us use another given, which is f of 7 equal to 0. When we evaluate f of 7, it means we have to substitute 7 for every x in the given function, so we will get f of 7 is equal to 7 minus b over 7 minus a. And since it's given that f of 7 is equal to 0, so this fraction, we will equate this to 0. So as you can see here, this fraction is 0 only if the numerator is 0, because 0 over any non-zero number, it's always equal to 0. So it is enough to solve this fraction as equating the numerator 7 minus b to 0. And we will get b equal to 7. Or if you want, you can do cross multiplication by putting the 0 as 0 over 1 and then cross multiply, and you will get the same thing. And then another given is f of 6 is undefined. So given that f of 6 is undefined, so let us evaluate f of 6 from this given function by substituting 6 for every x in the given function. So we will get 6 minus b over 6 minus a. And since f of 6 is undefined, so this fraction is undefined only if the denominator is 0, because if the numerator is a non-zero number divided by 0, that is undefined. So it is enough to solve this as x minus a equal to 0 and a is 6. In this activity, there are two questions. The first question is to fill in the blank. If the function is given as 3x minus 1 and another function is f of x plus 1 is equal to 11, then the value of x is. So here we can see that you will evaluate the function f of x plus 1 by putting or replacing x plus 1 for every x in this function f. And then after that, once you replace this x by x plus 1, then equate it to 11 and then find the x. So you can answer that question. And for question number 2, it's an application of a function. Jen offers a Wi-Fi installation services and he charges $10 per hour for his work in addition to $25 flat fee for each installation. Meaning, he charged an automatic at $25 installation for his service, and then for additional hour, he charges $10 per hour. So let H represent the number of hours he works for an installation. So the first question here is, we have to write a function that models Jen's earning for an installation. So you will transform this into a function according to the situation. So write your answer. And then for the second question, how many hours? So this question, letter B, is based on your answer in A. How many hours does he need to work if he wants to earn $175 from a single installation? So you can answer now. The next example is an example of a difference quotient, and this is where we will apply evaluating function. So find the difference quotient f of 1 plus h minus f of 1 divided by h, where h is not equal to 0. Because when h is 0, so this difference quotient is undefined. So our aim here is to get rid of this h that makes the denominator 0, or that makes this fraction undefined. So the given function is negative x squared plus 3x. So first, it's better if we will evaluate the function one by one, like evaluating f of 1 plus h, then after that is f of 1, then after that we can finally create this difference quotient and simplify. So let us start by finding f of 1 plus h. To evaluate f of 1 plus h, we will substitute 1 plus h for every x in this given function. So place this x with 1 plus h, place this x with 1 plus h, and we get this. And then in algebra, we will expand this binomial, which consists of three terms. So we will get negative of 1 plus 2h plus h squared. So I want you to recall this in algebra. Squaring the binomial is always a trinomial, or three terms. And then distributing 3 in 1 plus h, we will get 3 plus 3h. And then after that, getting rid of this grouping symbol by distributing negative in these three terms, so it will change the sign in each term. So negative 1 minus 2h minus h squared, then copying these last two terms. And then the next step is to combine like terms and writing with the highest power, h squared. So we will have the first term as negative h squared. And then the second term is combining negative 2h plus 3h. And then the last term is combining negative 1 plus 3. So we will get negative h squared plus h plus 2. So this is your f of 1 plus h. So we are done with the first. For the second step is evaluating f of 1. To evaluate f of 1, So substitute 1 for every x in the given function. So we will have negative 1 squared plus 3 times 1, and the answer here is equal to 2. So now we are ready. We're ready to create this difference quotient as copying this for f of 1 plus h and copying 2 for minus f of 1 then divided by h. Then simplifying the numerator by canceling 2 minus 2 because 2 minus 2 is 0. So we will left with negative h squared plus h in numerator and h in denominator. Then after that, take note, you cannot cancel this h here or canceling this h with this h because there's a plus sign in between. You can only cancel the numerator and denominator if the given operation is a multiplication. Okay, so this is a sum, so meaning you cannot cancel anything in numerator or denominator. So what you will do first is to write the numerator as a product or multiplication by factoring out the h. So if you will factor out h there, so it's multiplied by negative h plus 1, and this time you can cancel this h. But take note, if the given here includes h is not equal to 0, then you can cancel this h. Since we have h not equal to 0 is given, so we can now cancel this h because we can never cancel 0 over 0. Remember, when denominator is 0, it's undefined. Okay, so you can only cancel a factor if this factor will not give you 0 over 0. So now we can cancel this because we are sure that h is not 0. And then, as we said a while ago, our aim here in difference quotient is to cancel this h that makes this fraction undefined. So now we did it. We cancel the h, and the answer is negative h plus 1. So this negative h plus 1 is the value of this difference quotient for this function. The next example in difference quotient is difference quotient f of x minus f of 8 divided by x minus h, where x is not equal to 8. Because when x is 8, then denominator is 0. So our aim here again is to get rid of this x minus 8 because this x minus 8 makes the fraction undefined. So the given function is now a radical, which is square root of x plus 1. So here, so we don't need to solve for f of x because that's the given. So we will next solve f of 8. So when we solve for f of 8, substitute 8 for every x in the given function. So we have square root of 8 plus 1, which is equal to square root of 9, which is equal to 3. Then let us now create the difference quotient. So the difference quotient will now equal b square root of x plus 1 for the f of x, and then for the f of 8 is 3, and denominator is the same. So here, we cannot be able to cancel x minus 8 because x minus 8 is not given in numerator. And we cannot subtract 3 in square root of x plus 1, and we can never cancel this x with this x. The only thing that we can do here to be able to have algebraic manipulation is to rationalize the numerator. Why the numerator? Because the numerator contains a radical, and we can see two terms, so we can rationalize this by multiplying this fraction by its conjugate. So the conjugate of the numerator is the same terms with an opposite sign. So this negative, this becomes plus. So take note, I multiply this with square root of x plus 1 plus 3 and the same expression in denominator. Because if you multiply this with the same expression, so this is equivalent to 1 and the given will not change. So now let us multiply both of them. So in multiplying two fractions, we will multiply the numerator to numerator and then denominator to denominator. So let's do that. So when you multiply the numerator to numerator, you can see that there are the same first term and the same second term, but opposite sign. So we can use a special product by squaring the first term minus squaring the last term. That's the easiest way to multiply that. And then for the denominator, we would just join them or combine them with x minus 8 times this. Never expand this. Don't multiply just what we did in numerator because our aim, remember, in this difference quotient is to cancel this x minus 8. Okay? So next step is to simplify the numerator by squaring the first term, squaring the last. So we will get Squaring the first term, we will get x plus 1, and squaring 3, we will get the 9. So subtract 9 to this x plus 1. So I just copied the denominator. Take note, do not distribute because we're aiming to cancel this x minus 8. Now simplifying more in the numerator, x plus 1 minus 9, it will give us x minus 8. This is where we're waiting for the x minus 8 in numerator to cancel with x minus 8 in denominator. So now, remember, we can only cancel this if this x minus 8 is not 0. Since we can see here that x cannot be 8, then x minus 8 cannot be 0, right? So when x is not equal to 8, so we can now be able to cancel that. So the answer is 1 over square root of x plus 1 plus 3. So this is the difference quotient for this function. The next activity is about difference quotient, and there are two questions. The first question is true or false. If f of x is equal to m and m is an element of real numbers, so meaning m is a constant and the function is a constant function, then find out if the difference quotient given as this is 0. So you can answer this as true or false. For the second question is about spot the error. So here we have to identify and circle the mistakes, then write the corrections. So we will find the difference quotients of the given function mx plus b, where m and b are constants. So it is shown here, Aldana's solution of f of x plus h, and then given, or she rewrites f of x, and then after that she created the difference quotient as this. So this is the step 1, and this is the step 2 of Aldana, and the step 3 is she simplified the numerator into this, and the step 4 is equal to that. So she simplified this fraction into equal to 2b. So here you have to answer um, which is the mistake in this step. So the mistakes can be one step or two steps or more. So you can answer this question.